All right, Chapter 7, Section 4, Parallel and Perpendicular Lines, Master. So now we're going to actually talk about what it means for lines to be perpendicular. Well, in a nutshell, when you have two lines that are perpendicular, they intersect, but they form a 90-degree angle. Okay, that's what it means to be perpendicular. Okay, so we have a couple of functions here written in function notation, but that's okay. So we have f of x equals 1/3 x plus 4. So that's a y-intercept of 4. The slope is 1/3, so it has to run like this. Okay, and I will sketch in that line like so. It slid a little bit there, but not going to worry about it. So there we go. And I want to graph this one, g. I'll do that one red. The y-intercept is 1. Okay, but it has a slope of -3. So that would be down 3, right 1, down 3, right 1. Okay, and let's sketch that in. Okay, there. So you may notice, if you draw these reasonably well, that this is actually a 90-degree angle. Okay, let's try another one. Okay, so next, we want to plot this one, f of x equals 2x plus 1. So the y-intercept is 1, and it runs up like this. So let's get our line in place. Something like that. Okay, let's graph the other one. Has a slope of -1/2, a y-intercept of 6. So that's up here, and it's going to run like this. So we can actually see where it intersects. Let's change color. This is really, really slow today. Okay. Right. Okay. And once again, if you drew this properly, you'll notice that these two lines are perpendicular. They form a 90-degree angle. Okay, so let's summarize. What can you conclude about each pair of lines? Well, they, or I can just say they're, perpendicular. Perpendicular. Okay. What do you notice about the slopes for each pair of lines? So this one, well, they're a little bit trickier. When they were parallel, it was easy because you noticed that the slopes were just the same. But, well, it's clear that they're not the same. But clearly they are related, okay? So here I had 1/3. The 3 appears, but the sign has changed. Here I had a 2. So now it's just down here, and the sign has changed. So it looks as though they are related like so. Okay. It appears that the slopes are reciprocals of each other. So they're just flipped upside down, and then the sign has been changed. So the slopes are opposite in sign, but, oops, let's fill that in here, flipped. That's not really a technical term, but there we go. The slopes are opposite in sign, but flipped. For each pair of lines, multiply the slopes. What do you notice? Okay, so for the first set of lines, the slopes were 1/3 and -3. So let's multiply those together. We had 1/3 times -3. what happens when you multiply those numbers together? Well, you'll notice the 3's cancel, but your result is just negative 1. Okay, let's try it again with the other set. We had a slope of 2, and the other slope was negative 1/2. What happens when you multiply those together? Well, again, the 2's cancel, but you are left with negative 1. Okay, so that appears to be a pattern as well. When you multiply two slopes together that are perpendicular, the result is negative 1. So let's do this a bit more formally. Two lines are perpendicular if the what of their slopes is blank. Well, when you multiply numbers together, that's called taking the product. There we go. So if you multiply two slopes together and you get an answer of negative 1, then you know that they are perpendicular to each other. Hence, the slopes are opposite reciprocals of each other. So to go from one to the other, you just take the slope as is, take the reciprocal, you just flip it upside down, and then you change the sign. So if it's positive, it becomes negative. If it's negative, then it becomes positive. All right, so just like before with the parallel lines, we want to determine if these lines, each pair, are perpendicular. Okay, so we're going to test their slopes. So here the slope is 5, because this is written in slope-intercept form. This, however, is not written in any particular form, so let's take care of that. So we're going to add 1/5 x to both sides. So that gives me 4 plus 1/5 x. Okay, so now we can see that the slope of this line is 1/5. So are these lines perpendicular? No, they are not. Okay, because if you look at their slopes, yes, they are reciprocals of each other, but the signs are not opposite. They are both positive. So in order for these to be perpendicular, at least, well, only one of these could be negative. So the answer of this is no. Okay. Let's try the next one. All right, so we have y equals negative 3/4 x. This is in slope-intercept form. The slope is negative 3/4. Okay, that's easy to read. We look at the next one. Unfortunately, it's not written in a particularly nice form. So let's solve for y. It's already on the right and it's positive, so I'll just leave it there. So I'm going to add this, I'm going to take care of this 4/3 x, and I'm going to add it to both sides. So that's going to give me 8 plus 4/3 x equals y. Okay. Now we can see the slope of this line is 4/3. Okay, so check. They are reciprocals of each other, and their signs are opposite each other. Okay, so yes, if you were to graph these lines, they would be perpendicular, but we can tell without graphing that they are. Okay, and you can also verify this. You can take negative 3/4, multiply it by 4/3. In fact, you know what? I'm going to do that. Negative 3/4 times 4/3. Okay, well, you can see that the 4's are going to cancel, the 3's are going to cancel, and the only thing you're left with is the minus. So we just have negative 1. So yes, they are perpendicular. All right, last example. We can see that the slope of this line is 1. Okay, so in order for this one to be perpendicular, its slope must be the reciprocal of 1, which is actually just 1, but the sign has to be changed. So this has to have a slope of negative 1. So can we see that just by looking at it? Well, subtract x from both sides. So now it's in slope-intercept form. And you can see that the number in front of x, that's just an invisible negative 1. So yes, they are perpendicular. And you could also check 1 times negative 1, of course, is negative 1.